to introduce Roy Folkman from Embrionix, talking about another actual case study at a very important public broadcaster in Canada. So take it away, Roy.
All right. Thank you, Wes. And thank you, VSF, for putting on this IP showcase. Thank you for the other sponsors. Thank you for attending. This is a case study of CPAC in Canada, replacing a CWDM system with a real-time media over IP system. There are a few points on the title slide I want to make sure I get right, so I'm just going to refer to my notes on the title slide. But for context, CPAC is very similar in how they serve the citizens of Canada. They're similar to what BBC Parliament does in the UK, and what Phoenix does in Germany, and what C-SPAN does in the US. To begin, also, let me state that this is a CPAC project. I work for Embrionix. CPAC would be here, but they're in the middle of a national election in Canada, so I am presenting today. The slides were prepared by me, but submitted to CPAC for approval and made revisions, and they gave final approval. The contact information also for CPAC is on the final slide for Eitan Weiss. CWDM has been the default live production solution for video transport to remote sites. Compared to CWDM, real-time media over IP has numerous advantages, and this project capitalized on all those advantages, beginning with increased capacity and integrated routing. The project really illustrated these advantages. Also, it was completed in only 3 days of on-site commissioning and training, and then ready for air. So the agenda, I'll begin with the benefits to CPAC. I'll go into a bit about the company overview, some key points about the project, a description in some detail about the implemented system, and then how the system could evolve after initial implementation for additional functionality. And I'll give a summary. So benefits to CPAC, and I'm eager to state that this list of benefits took more than one slide, so there are 2 slides of benefits. So increased capacity on their system, integrated routing in an IP system, so in-band control, operational flexibility, non-blocking architecture, ease of future expansion. I already mentioned it was implemented very quickly with just 3 days on site. It was, for them, a comfortable first step into real-time media over IP from an SDI and CWDM system. It was compact. This was a 1RU switch at each of their 2 sites to begin with, and data integration, which is always an important factor, an important benefit in a real-time media over IP. It was simple, and it was cost-effective. So a bit about CPAC. I mentioned, for context, some of the other services around the world that do this, but it's commercial-free, it's not for profit, it's bilingual in Canada, French and English, an important window on Canadian politics and governmental proceedings and public affairs. It's owned by some of the largest cable companies in Canada, and those companies invested more than $50 million to preserve this editorial independent voice in Canada. It's available across Canada on basic cable and on satellite, on the web, and they have a mobile app. Some of the drawings I show go into some detail. This is a very simple drawing to begin with, but to introduce the convention. Throughout this presentation, when I give drawings, the CPAC studios will be shown on the right, and some detail about that, and then the government buildings, and it's a bit of a sprawl. This is multiple buildings that are included over on this site, but those 2 sites are connected with a single dark fiber pair, and I'll maintain that convention throughout the presentation. So the previous system, now just to be clear, this is the previous system implemented at CPAC, studios on the right, government buildings on the left. This is somewhat typical, I think you'll agree, a CWDM system being used to connect 2 remote sites, carrying signals and on this side, integrated with an SDI router. But as you know, CWDM is a point-to-point system. It really allows you to get signals from one place to another, and then you manually do something with those signals at the other site. So that same single dark fiber pair I mentioned before. In this case, as implemented, the CWDM system had just 8 signals in each direction. To be fair to CWDM, it can be 18. It is a point-to-point system, no integrated routing, and there were SDI bulkheads for some level of camera flexibility, be able to move cameras around and plug them into SDI bulkheads, but that was quite a limitation in SDI, which I'll get into in some greater detail. CPAC, as I think you'd also all agree, when a project goes well, it's often because there is one person who has a vision and understands the interests of all the stakeholders in the project and understands the workflow, understands technology, and that person in this case was Eitan Weiss at CPAC, and a great team he's got there working for him as well. So he's Director of Engineering, IT, and Technical Operations. Some key points regarding this project. It was a replacement of an aging CWDM system, and what was initially considered was just getting another CWDM system. But through conversations, it became really apparent at really about the same cost to implement an IP system and gain all those advantages. Initially, it's 2022-6, and I'm going to quote our esteemed moderator, Wes Simpson, here in his presentation that he gives, the 2110 tutorial, is 2022-6 will be around for a while, and there are applications when it's the right decision. So it's often worth a discussion, right? And this was a case. They're designing in a path to 2110, but initially, largely because it's implemented, there's still an SDI router after the first phase, more detail on that to follow. But the SDI router obviously has the audio breakaway capability, so you don't necessarily need the essence-based flows. You have that with the SDI router, and there's frame sinks around it, so you have that there too. So 2022-6 was a good, as I said before, comfortable first step into IP. And still significant benefits of IP were achievable using 2022-6. So integrated routing, non-blocking, geographic dispersion, increased capacity, ease of future expansion, reduced cost, ease of integration, all significant benefits. Now, cost reduction and simplification using 2022-6 initially, there wasn't PTP required, so no PTP grandmasters required initially, and it was, as I mentioned before, use of existing SDI frame sinks. The camera location, I mentioned the SDI bulkheads before. Camera location flexibility was a strong desire for the new project, and I'll go into more detail about that too. All the content initially is 1.5 gigabit per second. So now the implemented system. So this is the system. You'll see a complete IP system shown here, a 1RU switch at each location, that same single dark fiber pair initially. The switches installed have a total of 800 gig aggregation ports. So initially, we're just using one of those. Compact, those 1RU 48 port switches at each location. Integrated routing within the system. So as I mentioned, CWDM, you put a system in one side and you get it out the other, and then you decide what to do with it. Here you have integrated routing. So a camera, as example, shown on the left. That camera going into the IP system now is available everywhere. Every IP receiver endpoint now has access to that camera at the government Parliament Building site and back at CPAC. So complete flexibility, just taking advantages of multicast routing. Data integration, I mentioned. So in this case, the IT department is using part of that, using 1 gig E of the space for their own purpose. I'll get into another data integration or possible data integration application. SFP gateways, there are SFP gateways are installed directly in the switch, so not taking up any additional space. There are 2 channels per SFP installed directly in the switch, and both switches switch at the Parliament buildings and back at CPAC studios. the cameras, I mentioned a desire to have camera location flexibility. So we've got more fiber bulkheads for increased location options across 5 buildings and increased range. Now, at these cameras, at each of these cameras, we're converting to IP immediately, and this is using SFP gateways mounted in our enclosure. This is the size of a deck of cards. So converting to IP right there, and in this case, we implemented the fiber transceivers, our single mode LR. So now you've got 10 kilometers of range just with the cameras across this group of buildings. So incredible increase in distance and flexibility achieved right there. And again, the multicast routing, so every camera is available everywhere. Now on that single aggregation link used across a single dark fiber pair, you have a maximum capacity of about 48 signals in each direction, using just that, as I say, just that single aggregation port. They're initially just using 26 of the 96 available 25 gig ports, so there's plenty of room for expansion. 96 total ports being arrived at by 48 ports here at the apartment buildings and 48 ports back at on the switch back at CPAC. I emphasize again, a very important point, but just 3 days on site. Project rolled out very smoothly, and again, credit to Eitan Weiss at CPAC and his team for that. As you all know, CWDM is wave division multiplexing, so effectively modulating individual wavelengths with individual independent signals and utilizing that in a system, but some limitations. I often think of, I'm mentioning integrated routing here, but I mentioned in the past in the CWDM system, people would implement some control at the remote site, but they would modulate one of the wavelength with just the RS-422 signal. So you're then modulating a wavelength of fiber that's capable of gigabits per second with a signal that's 38.4 kilobits per second, right? So not making good use of the available technology. This is, I'm going to get into a few slides, a couple slides here about CWDM versus IP. So this is the CWDM system, a different view of it as previously used. Again, that single dark fiber pair, a maximum of 8 signals. And as I said, I want to be fair to CWDM, can be built to a max of 18 signals. Limited flexibility, point-to-point, no integrated routing, and now the IP system as implemented at CPAC. Again, that single dark fiber pair. Now you have a maximum with just that single aggregation port, as I mentioned, and there are 8 that could be used. With that single 100 gig aggregation port, you have capacity of 48 signals at 1.5 gigabits per second in each direction. There's no patching involved. The integrated routing with in-band control, integrated cameras with location flexibility and increased range. And in the future, additional gateways can simply be added, or processing functions, processing SFPs can simply be installed in the existing switches. This is showing if you used all 8 of the 100 gig ports, possible future expansion, shown in orange here. Now you're adding more dark fiber pairs for a total of 8. And if you did that, you now have 800 gig of uplink bandwidth between the 2 sites, 800 gig in both directions. That additional uplink bandwidth could be used to implement additional redundancy or to implement UHD on that system. Now, you could get up to a maximum of 48 UHD signals on the system if you implemented all 8 of those aggregation ports with 8 dark fiber pairs. So now I'll get into some of the future expansion possibilities and some of the additional capabilities that could be achieved. The system, as I've talked to previously here, a migration to SD2110 was designed in, so that can be done with a firmware upgrade to RSFPs that are used in the system, and obviously the addition now of a PTP Grandmaster on the system. Increased capacity, we've already shown. That's handled quite easily also. The control systems initially implemented, there is a separate control system for IP and a separate control system for SDI, but those could be unified initially or eventually, and then a single control system could control both. And then, of course, the SDI router can be replaced, and you could build out a distributed IP infrastructure, and then, of course, your control system is common. Remote camera control can use data integration to achieve camera control for cameras at the government buildings. I want to emphasize CPAC is not planning that particular function, but wanted to include it as an example of how to use data on an IP system. Could migrate to UHD. They could implement more IP processing functions on SFPs, so multi-viewers, up-down cross-conversion, compression, audio grooming, proc amp, frame sync could be added on SFPs. And in the future, when there are IP sources instead of sources and destinations instead of SDI sources, just new firmware could be installed on the SFPs, and they're no longer gateways. They can do IP processing functions on the system. Now, as I mentioned, the control systems could be unified. So a control system, the system could evolve to where a control system is controlling the SDI router and doing all the IP routing on the system also. So unifying that control. And then, as well, it could migrate to where it is entirely IP, so implementing a distributed IP in architecture. And you'll notice now here on the right, you've got what effectively a leaf spine architecture. And in this case, and the PTP grandmasters are shown there as it's now 2110. And in this case, the switch that exists at the Parliament buildings is effectively another leaf or another top of rack switch on the system without any blocking. So in this case, SDI router removed completely, and all routing is IP. And this is the data integration example I mentioned. Again, not planned at CPAC. I wanted to be open about that. But on the system, as wired, as built, now remote camera control could be implemented. So an operator now at the studios could have pan-tilt zoom shading control of cameras at the Parliament buildings. And we could do this by just adding a different box of ours. But you'll notice this box has one SFP that has an RJ45 connector on that. So a control cable from that, again, just using data on the network, could control a remote camera. And now sitting back here, you have remote camera control and shading control potentially. And now you also have video transport possibilities just from this box here. So another example of data integration. And I mentioned no new cabling required to achieve this new capability. So in summary, the benefits of IP compared with CWDM are numerous and significant. Integrated routing, increased capacity, operational flexibility, non-blocking, ease of future expansion, fast implementation, compact. There's data integration capabilities, and it's cost effective. And these were benefits to CPAC and also to CPAC's viewers, just based on increased production value that can be achieved. And ST 2022-6 is a viable, comfortable first step into real-time media over IP. Many of the benefits of IP can be realized with 2022-6, and of course, design in a path to 2110. It allows you to initially build a system without the requirement of PTP. Standard design practice, as you all know in our industry for SDI facilities, was to create a large centralized router, and then when additional locations or capacity expansion was required, you often added, say you added a second router, or you built a CWDM system to connect to another location. The blocking limitations around these techniques has caused substantial frustration. IP can be used to build geographically dispersed systems while maintaining non-blocking functionality. And there's a substantial install base of CWDM systems throughout our industry, these could migrate to IP to the benefit of users. Thank you very much. And I'll, Wes, if I could, I'll add one more thing and maybe break a rule. I'll step on some of my own messaging, but worth noting. Hope you find it interesting. But within an IP system, the QSFPs, the Q stands for quad. So each of in a quad 100 gig connection, there are 4 lanes of 25 gig, and each of those 4 lanes uses a wavelength. So effectively, it is a CWDM system within, but it's using, of course, it's using the specifications and standards and the IP protocols, and thanks to companies like VSF, SMPTE, organizations like VSS, SMPTE, EBU, AMWA, for developing those. So the power and COTS hardware, of course, but the power of the system lies in those standards and specifications.
Yeah, that's true. One of the nice things about the QSFP is it gives you a little bit more room to work, right? A little more.
Exactly.
A few more nano acres there.
Yes, exactly.
Yeah. So, question for you: what do you see as, anything that you would have liked to have done differently if you could have in this particular installation? Would you have liked to take another step, or would you have liked to architected it differently? I mean, let's say you get another project just like this, a week from now. What would you do differently?
Yeah, good question. It based on the discussions with CPAC, and as I said, they're a great bunch. This did seem like exactly the right fit, but of course, depending on future requirements, I mean, more capacity can be implemented. I mentioned data integration. That's always a big one that can help you truly benefit from the system.
Yeah, data integration would have been a big help, huh?
Well, I don't know that it would have helped them, but it's a big help in some cases for sure. Yeah.
For sure. Okay, any questions here from the audience? All righty. Well, thank you very much, Roy.
Thank you.